It is day 18 in geometry today. So I'm going to label this handout that we all have. Geometry. This is our day 18 handout. We will be using this for our notes today. So anything that I write on this paper, you should also write. That way, you're not missing anything. And what is it? It's Tuesday, November 4th. 4th. Thank you. Tuesday, November 4th. So, today we are looking at something a little bit different. We learned about polygons yesterday. Can someone remind me, what is a polygon? We wrote a definition.
Closed shape made with straight sides and angles.
Yes, a closed shape with straight sides and angles. No curves, no openings. These are all polygons. These are examples of polygons. But these are also special polygons. What's special about these polygons is that all of the sides are the same length. All of the angles are the same amount of degrees. So we give these a special name. Instead of just polygons, we call these regular polygons. E-G-U-L-A-R. Regular polygon. And what we can do to mark that these are regular polygons is put a tick mark on each of the sides. Triangles, 3 sides, all sides are the same. A quadrilateral that is a regular polygon, what would this specifically be? Could I give this a more specific name? If all 4 sides are the same length and all 4 angles are the same size. Square, I heard somebody whisper it. This is a square.
Okay, I didn't know if that was a trick question or what.
It is a square. So the other thing about polygons, quadrilaterals specifically, if in a quadrilateral one angle is 90 degrees, all the other angles, if all the sides are the same, should be 90 degrees as well. So this is just like a parallelogram where our opposite angles are equal and our consecutive angles, 90 and 90 makes 180, doesn't it? So 180 degrees, just like a parallelogram. Pentagon, 5 sides. 1, 2, 3, 4, 5. All of them are the same length. Hexagon, 6 sides, and this is a great way to count your sides by creating those tick marks. 1, 2, 3, 4, 5, 6. Now, many of you have heard, I'm sure, of some of these shape names. Have you ever heard of a heptagon?
Yep.
You have? Mm-hmm. Okay, that's one I feel like a lot of people have never heard of. Heptagon. That one's got 7 sides. Now, we could go through and add these little tick marks on all of these. So I'm going to do that now as we go through. 1, 2, 3, 4, 5, 6, 9. Should be 10 on the decagon. 2, 3, 5, 6, 7, 8, 9, 10. 10 decagon, that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And dodecagon, that's 12. 1, 2, 3. It's harder to see the lines the more there are. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Okay. Because every side is the same length, we can represent the side length with one letter. Side starts with the letter S. So we're going to use the letter S. I'm going to write at the top, S equals side length. And then I'm going to give you a new word that I bet none of you actually have heard of. I hadn't heard of it until the first time I taught this last year. That's like crazy to me. Have you ever heard of the word? We're going to write A equals.
Is that blue or purple?
This is purple. Opossum. Ooh, opossum. APOTHEM. Opossum.
Awesome.
A possum. A possum. It's like you're saying a possum, but you have a lip. I see a possum.
Oh my god.
That's terrible. A possum. So everybody make sure you can say that. A possum.
A possum.
Perfect. A possum. I'm never going to unhear that now. That it sounds like a possum. That is funny. So a possum is a special measurement in regular polygons. Specifically, we're only talking about shapes where every side is the same length, every angle is the same size. The opossum can be shown like this. I'm going to go to my hexagon, and I'm going to try to mark a spot right in the middle. It's okay if it's not perfect. That's not perfect for sure, but I'm going to put a dot in the middle, my center point. Now, from that center point, I am going to draw a dotted line going straight down to one of the sides. This length from the center to the side is the opossum. This is the opossum. And then we'll label also. I'm going to make this side right here red and put an S so I know that that's what side length is, just one side. So we have an opossum, we have a side length. We can use this on any regular polygon. The opossum of a heptagon would start from the center, and it would be the length from the center out to one of the sides. Now, the only thing that we have to be very careful about with the opossum, and we don't necessarily have to be careful actually, I take that back, because I will give this to you every time, but for your information, the opossum is measured only whenever it is at a 90-degree angle right here with the side length. So it's always the measurement whenever it's that perfect up and down, 90 degrees, like that. Do that on any of these. Dot in the center. That's my opossum. That's my side length. Works for every single shape. I give you one more thing to write down before we move over to a page of notes where we can use this, but also have this in our notes. We're going to get to some things that you probably have heard before. One more thing that we're going to need to know for each of these shapes is the number of sides. How many sides does it have? So we are going to use the letter N for number, to show that. So I'm right, N equals number of sides. N equals number of sides. So we have N, S, and A. So I'm going to put this little paper to the side for a moment, and I am going to get my notebook out. I am going to have you guys take a note here. First, I'm going to title my page, though, Geometry Unit 3. These are day 18 notes. And the title we are going to give our notes is Perimeter, Perimeter, perimeter and area of regular polygons. Give you some formulas. Today you actually are learning something new. Maybe you've seen this before. Does anybody know what perimeter is? The area around. That's kind of a good way, halfway there, or explaining it. It is talking about what's around the shape. Perimeter measures a length. How long are all of those sides put together? Perimeter measures the length, the total distance around the shape. So it is like saying the area around the shape. The only reason I say that's not all the way correct is because we don't want to describe perimeter as area, since area is something different. So perimeter is the distance around a shape. Here is a formula for that. We're going to use capital P for perimeter equals P equals N times S. N times S, where if we remember N is the number of sides and S is the length of one side, so side length. Perimeter equals N times S. And area we use capital A. Area equals perimeter, so P, times the apothem divided by 2. Say again, A equals apothem. And P is what we find in that first step when we find perimeter. These formulas you want to have somewhere that you can find them. Highlight around them real nice. Perimeter area. And let's use an example here. So, for example, let's say I want to find, find perimeter and area of, let's see, here's one example. Find perimeter and area. One, I'm going to describe a shape to you. The shape I will describe is a nonagon with a side length of 12.5 and an apothem of 28. To find the perimeter and the area of a nonagon with a side length of 12.5 and an apothem of 28. So, whenever we find perimeter and area, we always need to find perimeter first because we need perimeter to find area. So, not a bad idea to maybe number this as 1 for perimeter, 2 for area. You gotta do them in that order. So, for this example, let's find perimeter first. What is the perimeter formula?
Number of sides times S.
Yes, number of sides times side length, or n times s. So P equals n times s. So how do I know the number of sides?
Nonagon has 9.
A nonagon has 9 sides. This is where we can use our handout. I would find nonagon right here. It says 9 sides for nonagon. Now, normally there will be a picture. You won't have to memorize the names of those, but you could also be using this. So a nonagon has 9 sides. So, what am I plugging in for my perimeter formula?
9 times 12.5.
Yes, N is 9. S, the side length, I already gave it to you. S is 12.5. So now I have 9 times 12.5. And so my perimeter would be
112.5.
112.5. Yes. 9 times 12.5 is 112.5. Perfect. And I didn't give you units. Let's go with inches. So my perimeter is 112.5 inches. Now I have my perimeter. What is my area formula?
B times A divided by 2.
Good. P times A, perimeter times apothem, divided by 2. So, what goes into this formula?
112.5 times 20.
Good. 112.5 goes in for P. 28 goes in for A. You divide that by 2. So, let's do that. A equals 112.5 times A is 28. Divide by 2 at the end. So, let's see.
About part comes up to 3150.
Yes, 112.5 times 28 is 3,150. And we still divide by 2. We get
1575.
1,575 is our area. 1,575. What would my units be for area? Do we know?
Cubic inches.
Ooh, almost. Cubic inches would be 3-dimensional.
Would be feet.
Not feet. It's inches something. Square. Inches square. Square. And the reason for that, if you are curious, is that in the top part of our problem, I have, we did something sticky note. I have on the top part here 112.5 inches is my unit. And I'm multiplying by 28 inches again. It's just like if I do x times x, I get x squared. This is inch times inch gives me inch squared. Well, FYI. That's why. So if you don't want to have to just memorize that it's inches squared, that's why. That gives us inches squared. You could just memorize it though. That's okay. So that's our perimeter. That's our area. So, does anybody still need to see this before I move to the next thing? Okay, I'm going to flip to the next page and let's try a few more examples. So, this is page 2. Okay, continue. And this time we're still finding area and perimeter. Oh, I'm going to file this again so I can find it. Area. Now, let's draw a picture this time. Do your best job. It's okay if it doesn't look great. We're going to try to draw a pentagon. 5 sides. I'm not even going to use a ruler because I know I'm not going to make it perfect. I'm going to start with an angle like that. There's my 2 sides. And then I'll draw 2 more lines coming down. And then I'll draw my 5th line. There's a pentagon. 5 sides. And inside this pentagon, I will give you an apothegm. Give you some length. Let's say this is 4.3 inches. And let's say this here, my purple line, is 5.1 inches. I'm going to rewrite my formulas on a sticky note so I can move it around. What do you start this?
Bunch of green.
Find the perimeter. We want to try to find the perimeter. What do I need to find the perimeter?
Number of sides and the length of the side.
Yes, I need the number of sides. I need the length of the side. So I'm going to count my sides. 1, 2, 3, 4, 5. Okay, so I'm going to keep track of this in this 5. I have 5 sides. What's my side length?
4.3.
4.3. So S is 4.3. Now I can find the perimeter, can't I? What do I do with those numbers?
Plug them in your formula.
Plug them into the formula
Multiply.
and multiply. Good. So, perimeter. Let's do P equals times 4.3. And what do we get when we multiply 5 times 4.3? 21.5. What are my units? Inches. Good. 21.5 inches. Nice. Got that. How can I now find the area?
5.1.
We want to take that perimeter, multiply by 5.1. That's the apothegm. Okay, so area equals my perimeter, 21.5 times 0.1. And is that all I need to do?
You have to divide it by 2.
I will also need to divide by 2. So, what's nice about the area formula here is we are used to when there's a fraction, you have to do the top part first and then the bottom, because a lot of our formulas we've used in the past, especially in like algebra 2, have addition and subtraction all mixed in there. Because this is all multiplication and division, you can actually type it in all at once and it won't mess up your answer. I can just type 21.5 times 5.1 divided by 2. And I get, is that what you guys are getting?
Yep.
54.825?
Yep.
Okay, nice. Never hurts to double check. You can also do it separately. It makes you feel more confident about it. Yeah, I got the same thing doing it the other way too. So our area equals 54.825. What are my units?
Inches.
Inches squared. Good. Inches squared. And the other thing that we can think about when it comes to the units, perimeter, we're only measuring it in regular inches because we're measuring a line. Lines are measured in inches. The area, we're measuring a flat space that we measure in, we're basically saying I can fit 54.825, so almost 55 inch size squares inside of this shape. That's what area tells us. How many inches in the shape of a square can I fit in this shape? That's how we do it. And it is that. Let's do one more, make sure we got it. This time I want us to find area and perimeter of a dodecagon. Where the side length is 18 centimeters and the apothem is 20 centimeters. I want to find perimeter and area of a dodecagon with a side length of 18 centimeters and an apothem of 20 centimeters. Feels like they can do this. You know, maybe you can guide us through this specific one. Give you guys time to figure it out. Just jump in when you think you're ready.
You would do centimeters squared for this.
We would use centimeters squared for this.
Okay.
Yes.
Okay.
Yes. Bless you. idea how we could start this one?
18 times 12.
18 times 12. Oh, how do you know that?
Yeah, 12 sides.
Okay, the dodecagon has 12 sides. You know that by looking at this here. Dodecagon, 12 sides. So I know that the number of sides in is 12. 12 sides. And the side length is 18. I gave that to you, so you're exactly right. To find perimeter, we do 18 times 12. So in is 12 times x is 18. This time I'll put the units in my work. You don't have to do that, but I'm going to do it this time. Now, are there units for 12?
Well,
No.
Maybe sides.
And sides. I guess sides would be the units. There are 12 sides. So, what's my perimeter? 216 times 18. Yep, 216. What?
Centimeters.
Good. 216 centimeters.
Times that by 20. And divided by 2.
Yes, yes, yes. All we have to do to find apothem next is take that number times the apothem 20 divided by 2. So, area equals 216 centimeters times 20 centimeters divided by 2. And if using colors and stuff like this is helpful, you can absolutely do that. Maybe I'll say, centimeters, maybe say like the bottom is orange. Side will be orange purple. Yeah. Blue. Green. You don't have to do all this. I'm just trying to think of a way that might make it easier to look back at later and see what happened. Okay, so I have everything now plugged in to find my area. So what I'm going to do in my calculator is if you just found your perimeter, 216 is already typed in for you. We could just go ahead and type times 20 divided by 2 because it's going to take 216 as your answer. Times 20 divided by 2. 2160, is that what you got? Perfect. So, area equals 2,160 centimeters squared. How does that feel, you guys? Feel pretty doable, or would we like to run through another together?
That's pretty doable.
Give me thumbs up if you like, I got it. Give me thumbs in the middle if you could use more practice. Thumbs down if you're completely lost. I can see mostly thumbs up. That's good. Good. Okay, let me give you one to try by yourself. Let's see how we do. This time, I will give you a heptagon. Heptagon with a side length of 21.3 and an apothem of 2.5. Find the perimeter and the area. pause this recording for a moment, see how we do. Okay, so the problem that magically appeared to people watching the video, that was an extra. You finished the other one early. So, looking at the first one, I have a heptagon with a side length of 21.3, apothem 32.5. Who can guide me through this? Who's got it? Anybody want to give it a go? 21.3 times 7. What's that going to give you? 149.1. What did we just find? Perimeter. Okay, so I'm going to write all that down. A heptagon has 7 sides. So the number of sides is 7. To find the perimeter, we do n times s. So 7 times 21.3. And our perimeter is 149.1. What are my units? Centimeters. Good. Got my perimeter. How do I find area? Yes. Perimeter times apothem, 32.5. So 149.1 times. Yes. Perfect. Divide by 2. Go ahead, you're right with me. 2,000.
422.875.
Yes. 2,422.875 units.
Yeah.
What are my units? Centimeters squared. Perfect.
Did we get it wrong if we round up the decimal?
No, you won't get it wrong. So did you put like 0.9 or?
Yeah.
Perfect. Yep. If you did 2422.9, I would count that right. I would count it right if you did 0.8 as well. I'm not worried about you being able to round. That's okay. If you did 0.8, 0.9, you could do 0.87, 0.88, or all 3 of the decimals, 875. Any of those are good. Okay, nice. Did anybody get the second one done? You did? Okay. Seth, can you show me or tell me how to do it? Not put it on the spot.
Also, being gone is 17 sounds.
Yes, we learned yesterday any number gone just means it has that many sides. This has 17 sides. So that's my n.
So 17 times 5.4.
Good. 17 times.
That was a trick.
Uh-huh. 17 times 5.4. Beautiful. My perimeter is 91.8. What are my units?
Inches.
Inches this time. Good. Okay, so we found our perimeter.
Now we times that by 12.3 divided by 2.
Good. Now we take perimeter, 91.8, times apothem, 12.3. Divide that by 2.
Something is 1,129.14
Perfect.
divided by 2 is 564.57.
Perfect. 564.57 inches squared is the area. Very, very nice. Perfect, you guys. Okay, it is 1:58. It is just about 2 o'clock. We have done some really good work for this first half here. So I would love for y'all to take a little break. And we will come back at 2:15, finish up just a little bit more. And then I'll give you an exit ticket. So that is it for the first half today. I'm gonna go ahead and pause our recording. Feel free to say if you have questions. But feel free to take a break. We'll be back at 2:15. Okay, so we are back from our break. And what I'm gonna have you do now is we're on page 2 of our notes. I'm gonna flip my page and make a third page. We're not talking about 1/2 more things. Okay, so let me title this. We are, bless you. This is still day 18 notes continue. Day 3. So we just did some problems where we were finding area and perimeter of regular polygons. But the other thing that we're specifically focusing on in this unit is quadrilaterals, four-sided shapes. And we want to also talk about area and perimeter for not regular polygons. So I want us to start here for area and perimeter. This is going to be specifically for quadrilaterals. We're going to be talking about the ones that we talked about yesterday. So parallelograms, rhombuses, rectangles, squares, all of those. Bless you. Bless you, bless you. Right. So what I'm going to do here is I am going to give you a formula. A equals B times H. B is for base, H is for height. Find the area of a parallelogram, for example. Let's draw a little parallelogram. Over to the side, I am going to start with a tilted line that is 1 inch long. Then I'm just going to slide my ruler over and another 1 inch long line. Connect my lines. Make sure your side from the bottom, this is going to be your base. For the purpose of your notes, it would be good if your base is flat, like this. So if one of your lines needs to be extended or shortened, that's okay. This is a parallelogram. And on a parallelogram, we have opposite sides are equal. The base is on the bottom. So I'm going to put a B here on the bottom. If the base is here on the bottom, and I know opposite sides are equal, what would the length of this side right here be in relationship to the base? They'll be equal. These will be the same. If it helps, let's draw little tick marks. I know those should be the same. One tick mark on the other opposite sides. Now our height is measured in a very specific way. We go from the edge of that top side, and we're going to draw a little dotted line. We make a right angle. This is our height. Measures how tall is it?
Where could we put it? Well,
If we did it where?
in the middle.
In the middle, that would be fine. As long as you know it's going at a 90-degree angle, then it's just fine if it's not right on that little corner. Now for perimeter of something like a parallelogram, have a formula. On the other sides here, we're going to label that with an S for side length. Now with a regular polygon, we were able to just take the number of sides times one side length because all those sides were the same. So we're basically just adding all the sides together. Here, we're also still adding all of these lengths together. We're putting them all together. So I need to add the base plus the base plus the side plus the side. There's an easier formula for this rather than having to add all four things. We can do 2 times base plus side because we're adding both of them twice. Or you can just add all of the sides together. So for this parallelogram that we've drawn, and now using these formulas, what if my parallelogram has a height of 3 inches, a base of, let's see, I'll make it accurate. If that is, I don't know. I'm not gonna make it accurate actually. We'll say the base is 4 inches. And we'll say the side is 3.5 inches. I find my area and my perimeter. We'll start. It doesn't matter which one you do first this time because I don't have to use the perimeter to find my area like with regular polygons. So I'll start with area because I got that one written first. So if I'm gonna find the area of this polygon, we're using base times height. What do I plug in for the base?
4 times 3.
Which one?
4 times 3.
4, yes, for base, and then 3 for height. Good. So 4 times 3. So my base is 4. Let's plug that in.
Is it still going to be squared?
Yes, it will still be squared. Good. So this is times my height is 3. Some colors in here. What's my area? 12 inches squared. So now if I want to find perimeter, we'll use the other formula. Perimeter equals 2 times the base plus the side. I'll use the same blue for base. Now what mixes people up is our side length is not the same as our height.
That's different.
Different. I'm gonna go with green. What is our side length?
3.5.
3.5. So I need to use that. So 2 times what goes in our blanks?
4 plus 3.5.
4 plus 3.5. Now, there's a couple of ways that we could solve this. This just goes back to order of operations, our basic rules of how we solve problems. What is one way that I could solve this?
Your parentheses first.
Take care of your parentheses first. So how do we do that?
You're gonna add 4 and 3.5 together.
Yeah, we can start by adding 4 plus 3.5, and that gives us 7.5. Bring down my 2, and that gives us a perimeter of 15 inches. So we can do it that way. Or if we really want, it's just another way that we could do it. Does anybody know a different way we can do it? We could do that times 2 first. We could distribute where we do 2 times 4 and 2 times 3.5 and then add. Either way, we should get the same answer. I think the first way might be quicker though. 2 times 4 is 8.
Plus 7.
Yep, plus 7. And 8 plus 7 is still 15. Both ways will work. Whichever way you're more comfortable with is just fine. Nice.
So perimeter will always be just inches and then
Yes.
area will be inches. But inches
Yes,
squared.
Perimeter is always inches or
I was gonna
centimeters
say,
or
I
whatever.
didn't know. I
Yes.
didn't know.
And then our area is always squared. Let's try another one of these. What if now I have a square? I have a square. I'm gonna draw a square.
Didn't someone be able to do it like the other way?
Actually, yes, you could, if they give you an apothem. But if they don't give you an apothem, you need to use these. So let me see, let me draw a square. I'm gonna do 3 centimeters for my sides.
They're all 3 centimeters is the possible. But
Yeah, it would be. It would be. You're very smart. I didn't even think of that. Okay, so I'm gonna label this my bottom with, we'll use a different measurement though. Let's go with like something random, 9.2 centimeters. Now with the square, a few things that we know. First of all, I would have marked that all 4 sides are equal. We also know that a square has a 90-degree angle here. And all 4 corners, really. So let's think through this one. First, let's try it using these formulas. If I wanted to find my area, I need a base and I need a height. I only gave you one number though.
Wouldn't they all be the same?
yeah, wouldn't it be 9.2?
They would all be the same. 9.2 is the same as every other side because of that single tick mark. That's what tells you. And it's a square, all 4 sides. So if we want, we could label the rest as 9.2 centimeters. Or at least just one more. So my base is 9.2. What's my height? It's also 9.2. A square is special because the side length measures at a 90-degree angle like the height needs to. So they're both 9.2. And what would our area be?
84.64 centimeters.
Perfect. 84.64 centimeters squared. You're exactly right. Very nice. Very, very nice. So I found my area. How do I find perimeter?
Times base plus 2 times base plus side.
Yeah, 2 times the base plus the side. What's my base? What's my side?
1,
9.2 and 9.2. My side length is the same as my height here. So 2 times 9.2 plus 9.2. There's an easier way to do this.
2 times 2.
Yeah, times 2 times 2. Let's see, what do we get? 9.2 times 2.
36.8. That's the answer.
Good. So perimeter is 36.8 meters. Now a square, as Jaden noticed, is a regular polygon. All the angles are the same, all the sides are the same. You technically could use a different formula. I know that perimeter of regular polygons is the number of sides times the side length. Didn't I just do 9.2 times 4? Yeah, it'd be a little faster.
Your approximate would be 4.6.
The apothem would be 4.6. How did you find that?
Divide 9.2.
Yeah. So we know the apothem is from the center of the shape down at a 90-degree angle. This lines up with the side perfectly, and it's at the halfway point. If I wanted to know the apothem, I could just take 9.2 divided by 2. Interesting.
And you just, you, what? Add them and divide it, or add them and divide it.
Times what and divide what?
Perimeter,
Mm-hmm.
and the approximate, and then divide by 2.
Yeah, let's see if that works. Let's see if it gives us the area. This is just for fun. You don't have to write this part. So if I wanted to use the regular polygon, we know it's perimeter times apothem divided by 2. Perimeter is 36.8 times, we said our apothem is 4.6 divided by 2. Let's see if it gives us the same answer. Works. It works. We did the same thing, 84.64. Neat.
Non-circle. Square.
Squares are nice. They make things easier. Everything's the same. Okay. Good. So let me give you something to try before I move this. Does anybody still need to write anything? Or do we have any questions about any of it? Anything at all? Okay. Get my page. And let's see.
Goodness. There you got something.
What is this, page?
4.
Yeah, page 4. Because we have a lot of examples. We wouldn't have so many notes if the printer was working. Then we wouldn't have to draw everything.
That makes sense.
Yeah. So this time, let's do a rhombus.
Oh boy.
A rhombus. What do we know about a rhombus?
What's that?
Got 4 sides. Start with a side that is 2 inches. And then I'm going to tilt this up and do another 2 inches. Okay, so both of these are 2 inches. Then I'm going to take that second side I drew, shift my ruler over, try to keep it around the same angle. Actually, I'm going to do it this way. We're going to do 2 inches from that second side, right here. And now my fourth side be a little easier. Okay, so we know a rhombus has 4 sides. What do we know about all 4 sides of a rhombus? They're equal. All the same size. I'm going to also tell you that the rhombus will have a height. This time, I'm going to give you my side length is, so the actual measurement, let's go with 2 inches. And then our height, let's see what our actual height would be. And let's see. That's not 16. I'm going crazy. Okay, so my height is 1.375 inches. How could I find the area and the perimeter?
2 times 1. 375.
So 2 times my height, 1.375. How did you know to use 2 for the base?
Because they're all equal.
Because they're all equal, like a square. If my side length is 2 and I have it marked that all the sides are the same, my base must also be 2. Everything is 2 inches. They're the same. So we're doing base of 2 times height, 1.375. So let's multiply. 2 times 1.375 equals. Good. Area is 2.75. What are my units?
Inches squared.
Inches squared. Good. Can I find perimeter?
2 plus 2 times 2.
2 plus 2 times 2? We can do that. Absolutely. If I'm using the 2 times side and base added together, my base is 2, my side is 2. What do we get? We get 8. Eight what? Inches. Yeah. 8 inches. Oh. Area and perimeter, that's what we've been doing today. That is good. Okay. We have a worksheet I made for the regular polygons, but now we've gotten ourselves all out of order. I'm gonna pause this. Okay, so quick check-in. Magical opossum appeared. This is a possum. And speaking of that, you're gonna need to use a possum whenever you do the exit ticket, which I just gave you all. You're gonna find the perimeter and area of number 1, you have a square. Number 2, you have another shape with, I believe, it's gotta be, that's a hexagon. Yeah. So this is your exit ticket for today. You're more than welcome to stay if you want to have any more help on this. Today ended up being a little kooky, I feel like, but that's alright. If you finish, you are free to go. However, I'm not kicking you out. You're welcome to stay. Alright, that's gonna be it for today. I'm gonna end our recording.